This tutorial is to show you how different loops work. Here I've made a program and I am going to loop through the numbers 25 to 11. I'm going to go down by 2 each time. So I start at 25, I go 23, 21, 19, 17, so on. I also have a list box on the form. This is button 1. So if I double click on button 1, if I want to create that sequence of numbers, which I've also pasted here, I first have to declare a variable. Then I have a for loop. I say what my first number is. My first number is going to be 25. I'm going down to, when I initially set this up, I said the number 10. As I go down, you need to say that your step is going to be negative, so I'm going down 2. Each time I add the number to the list box, which is I, as it changes. So first number going in will be 25, next will be 23, next will be 21, and so on, until I can get down to the number 10. And I'm not able to go down any further because the next number would be 9, so the last number you'll actually see displayed is an 11. So this is a pretty self-explanatory loop. Now, on the next one, I'm going to be doing incrementing. What incrementing means is going up by 1. So I'm going from the values 4 to 7, and I'm incrementing because you can easily see 1 added onto 4 is 5, 1 added onto 5 is 6, 1 added onto 6 is 7. So whenever I go up by 1, I call that incrementing. Don't forget that. You're going to see that on future tests and quizzes. So the normal parts of this have to be available. For this particular loop, I'm choosing to do it with a do-while loop. It would honestly even be easier probably if I did it with a for loop, but I'm going back and forth so that you guys get a little bit of experience with both. So the first thing I need to do is declare the variable. I'm going to set I equal to 4. The loop does not really begin until you say something about do while, and it doesn't really end until you say something about loop. So I'm going to do this while I is less than 7. Now I've initialized it. I've got a test. The final thing I have to have is what? I have to have an update. So this is what is going to update my loop control variable. My loop control variable is I. It's what controls whether I'm in the loop or not. So the update is going to be I is equal to I plus 1. Now there is another way of writing that, but for right now, let's go ahead and first make sure this works. I'm going to say listbox1.items.add parentheses I. Now if you want this to work, there's a little bit of an issue here, because if I want to see the number starting at 4 and actually going up to 7, I'm going to increment it, so the very first number I'm going to see here after coming in with a 4 is going to be a 5. That's going to cause a problem. You have to be very, very careful where you add something to your list box if you're trying to produce a certain sequence of numbers. I think I'm going to have a better result here. I start at 4. I add it to the list box. I keep going until I get to 7. I add that to the list box. If I have it after, I will start later and end later. I'll actually make it all the way to the 8, so you have to be very careful about this. Now, in your notes, we have some important terms here. First term here I have is a loop block. A loop block is everything from the first line to the last line, not including the first line to the last line. So for this particular loop, this is my loop block. Let's go ahead and run it just to make sure that I actually produce the sequence of numbers 4 to 7. There we go. There's the numbers 4 to 7. So again, you have to initialize, you have to test, you have to update. Don't forget that. Again, this is my loop block. My loop begins here. It actually ends here. With a for loop, you also have a loop block. For this particular for loop that I have here, the loop block actually consists just of one line. So this would be my loop block here. Always when you do a for loop, it's always good to say what your loop control variable is here. When you say next, always say what that variable is. It should match whatever you say here. Okay, let's go back down to my notes. You guys now know what an incrementer is. An incrementer is actually the line of code that adds 1 each time. So I would have to say this is my incrementer. That's an incrementer. Now there's other kinds of code that I can have. I can count And actually an incrementer is a type of counter. A counter is a little bit broader. An incrementer always goes up by 1. To me, a counter means that it goes up by some fixed amount. So we could go up by 3 each time, or we could go up by 4. Or maybe we could go up by 1, which would make it an incrementer. So an incrementer, in my mind, is a counter. But a counter may not be an incrementer, because a counter is kind of a broader expression. Let's see an example of a counter. I'll go ahead and paste another button onto here, and this time I'm going to start at, say, 5. And I'm going to count up by 5. So I'm going to have 5, 10, 15, 20. We can end this at any time. I hit return. I want to make sure that I call this a counter. Now, let's go ahead and go to the code. And the first thing I need to do is I need to declare a variable. So again, I'll just call it I, dem I as integer, for I equals 1, 2. Now, how far did we go? We went to 20. We're actually starting at the 5, so I need to say 5 to 20. If I'm going up by 5s, what do I need to write next? Step 5. So that should get us there. I don't like the way this is written. Let's be specific. Visual Basic will compile as I have it right now, but I do want to say next I. It's just a little bit better looking code. Now let's add that number to the list box. So I will say listbox1.items.add I. Now, so that we're not getting confused with other lines of code that we've written or other things that we've done on other buttons, let's clear off the list box. Listbox1.items.clear. We'll do that at the beginning of each of our buttons. So I'm going to scroll up and put this line of code on each of the buttons I've done before this. Now, let's go ahead and see this counter in action. It's going to go up by 5 each time. So if I rebuild this and I run it, there obviously this is a counter. It is not an incrementer. An incrementer only goes up by 1. This goes up by 5. Now here I have an incrementer, but I also say because it's going up by 1, this is also a counter. I have no problem calling that a counter. A lot of people get this confused. I'm sure you will have professors in the future that contradict me right now. So if they want to say this is a counter and they're going to get mad if you call it an incrementer, you just call it whatever they want you to call it. Okay? So everybody's got their own vocabulary. This is what I call an incrementer. The other is what I call a counter. I would even go so far as to say that if you add a -3 each time, since you're adding a fixed amount, I'd have to call that a counter too, even though you'd be becoming smaller each time. Okay, let's see what else we have here. Okay, next thing I've got here is a decrementer. Let's go take a look at a decrementer. I'll do a decrementer in a while loop. Again, I'm trying to go back and forth. Now, last time I did a do while loop. I'll make a slightly different type of loop here. I'm going to start off with do while. So far, everything looks the same. And then I'm going to say while I is, we're going to count down to 0. So I'm going to say do while I is greater than 0. At that point where I becomes less than 0, we're going to stop. And then I'll hit return. I need to declare the variable up here, so I'll say dem I as integer, and let's go ahead and initialize it. I'll set it up to the value of 10. We're going to count from 10 down to 0. Now down here, I'm going to write the line of code that is actually a decrementer. If I write it in terms of I, what do I write to create a decrementer? Now, of course, an incrementer is something goes up by 1. A decrementer is what? Goes down by 1. So I'm going to say I is equal to what? I minus 1. So obviously that is a decrementer. While we're talking about this, there is another way I can write this line of code. Let's go ahead and run it first to make sure it's working right. I'll say listbox1.items.add. And I'm going to add I. Now, do I have all 3 parts of a loop here? Do you see all 3 parts? What's the first part? Initialize. Right there it's initialized. What's the next part? Test. There's my test. Is I greater than 0? Do I have my third part? What's the third part? Update. So here I'm updating the loop control variable, which here is an I. Let's go ahead and rebuild it. Just make sure everything's working the way it should. So I'm going to start at 10. I'm going to go down to 0. I have made a mistake. Do you see the mistake? What did I do? Something I told you to be very concerned about before. Yeah, watch where you add something to a list box. Pay real close attention to whether you're doing it before your loop control or your update expression or after. So it makes a big difference if I have listbox items.add here or one line above where I decrement. And I would have gotten the result I was looking for had I put it above. Now, if you know what's going on, of course, you can always put it after, and you just take into account where you start and where you end and just adjust accordingly. So you can make it work the other way. It's just a little easier to see if you do it this way. So I'll go ahead and start it now. Let's see if I actually... Oh, I'm writing the wrong thing on the button. Let's actually say what this is. We're going 10, 9, 8, down to 1. And I'm going to call this a decrementer. Okay, let's go ahead and rebuild this and see if that's what we get. So if I click on this, I go all the way down to the 1, you see nothing else. Everybody see what's going on there? So that's a nice example of a decrementer. Well, I was going to show you something else here. You guys have now seen a for loop. You guys have seen a do while loop. I'm about to show you a do loop while. So here is a do loop while. It goes just like this. You know how we just wrote this code? You see the statement here where it says while I is greater than 0? That's the test. It doesn't have to go here. I'm going to cut it off. I'm going to hit Control X. I'm just going to move that down after the loop condition here, and I'm going to paste it. I haven't changed a thing in that whole statement, while I is greater than 0. I rebuild it, and you will notice it compiles. What's interesting about this loop is there is no test at the beginning of the loop. You must get in and run through one pass of the loop because of that in the beginning. The test comes at the conclusion. You either meet the condition or you don't. And at that point, you may exit the loop or you may go on. At that point, there's no difference between this and a normal while loop. The real difference is, do you want to make at least one pass of the loop or not? So sometimes this is a handy loop to know about. So I wanted to add this to what I did. Also, I taught you a little bit about what a decrementer is, so don't forget what that is. Now again, guys, let's throw in a counter here just for the heck of it. I'm going to say dim, I'll call it C as integer. And let's say instead of decrementing, I want to count using a integer. And I'm going to start, say, at 3. And I'm going to count up by 3s all the way up to 12. So I'll have 3, 6, 9, and 12. Now, what is the code for a counter? What would that code be? C equals what? C plus what? What are we going up by? 3. We do need to initialize it to a correct value to start with, so I am going to set it off at 3. I add it to the list box, I go up by 3, We need to fix the loop so it goes up to the right point. If I'm going up to 12, I want that to be my last value that I report. How do I change the condition here? What does this condition become? While C is what? Anybody tell me? Less than or equal to 12. We want to get in on that last pass, so we report the 12. Now again, the line of code I just wrote here is a counter. I did it within a while loop because it's so automatic. Within a for loop, you really don't see that there's a counter equation built in. So that's why I made a big deal out of this. Let's go ahead and rebuild this. We'll run it. I click on, actually right now the button is not appropriate, is it? Because it says it's a decrementer here, and that's really not true. We're counting up by threes from 3. We should see 3, 6, 9, 12. And we don't see it. What's wrong? Well, I slipped up. We should have added each time the value is C. So let's go ahead and rebuild this. And let's run it. And boom, there's those numbers. So this is employing a counter. Now, I've talked about counters. I've talked about incrementers. I've talked about decrementers. The final thing you really need to know about is something which is called a running total. So this is really about a running total. Now, a running total has a real important use in computer science. I've got to say, some of the most important lines that we use in computer science are incrementers, decrementers, counters, and running totals. If you know those 4 things, you're going to just take care of a lot of stuff you're going to have to do in the future. So if you can get this under your belt, this is really important. Let's see what a running total is all about. Best example I can think of running total is like if you have a bank account and each month you can only afford to put so much in the bank. It probably changes from month to month depending on what your expenses are. So let's just go ahead and create a total variable. So I'll say dim total as integer. Now, if you're talking about a bank, what does your bank balance start at before you even open up a bank account? Well, obviously it's going to be 0, right? The bank's not going to give you any money just for free. So now let's go ahead and develop another variable, which is that amount you're going to add from month to month. So I'll declare that variable as dim amount as integer. If you want, you can set this initially equal to 0, but it's whatever you can afford from month to month. Now, I am going to keep a running total for 5 months. So when I hit that 5th month, we're done. So probably about the easiest loop I can think of, if I'm going from a definite beginning to a definite end, I want to use a definite loop. What is an example of a definite loop? A for loop. An indefinite loop is a while loop because sometimes you have no idea how long you're going to be doing your looping. So a for loop is great where I know the definite beginning and the definite end. I'll say for I equals 1, 2, 5. That should take me for 5 months. I also need now a variable of I as integer to make this loop work. I'll hit return here. It gives me next and I. One of the things you need to know is, what does that first line of the for loop look like? What does that last line of the for loop look like? Don't forget that, because sometimes, as you just saw, Visual Basic will leave your code off and it won't do it for you. Now let's go ahead and make a running total. Now I'm going to say amount equals, we'll gather the amount from an input box from the user. So we'll say input box parentheses, quote, enter the amount of your deposit this month. I'll hit return. Now, what I need to do is, that's the amount you're depositing in the bank. So obviously, if I want to work up a way of taking your total and having that total reflect the latest amount that you've just deposited into your bank, what's this line of code going to look like here? How do I write this? total equals what, guys? Sure, whatever the total was last month plus this newest amount coming in. Does that make sense? Do you see why this is different than a counter or an incrementer? Again, just like with a counter or an incrementer, I'm adding on some amount every month, but with a counter, that amount is fixed. Here, with a running total, I have no idea how much that amount is going to be, so that amount is going to be variable. That's what tells me this line of code is a running total. It's a line of code that I execute over and over and over, where I come in with a different amount and I'm adding it on to the total that I have. And probably the best example you can possibly think of for this is a bank account. It's very, very typical of where you use it. So if you know this tool, if you feel good about the things I've already talked about, these will come in very, very useful for everything you do in computer science in the future. They're just something we just use all the time. Okay, let's go ahead then, and after our loop, we'll go ahead and we'll see how much you have in the bank. So I'll say listbox 1.items.add. We'll add total equals, and then I'll concatenate onto there our total. Let's make this look like money, so I'll say format what? Currency, right? And I'll put that around total. When you format currency, it has the effect of taking the term, turning it into a string, putting a dollar sign in it, and giving you 2 places by the decimal. Yes, this just became a string by saying format currency. Now, let's go ahead and rebuild this, and let's run it, and let's see if it's right. Here's my running total. First month, let's say I could only afford $10. Remember, I'm only doing this for 1 to 5 months. So if you think about this, before I even do this, I'm going to run this in Notepad. 5 months. There's month 1, 2, 3, 4, 5. First month, I'm going to put in 10. Second month, I'm going to put in 20. Third month, I'm going to put in 30. Fourth month, I'm going to put in 40. Fifth month, I'm going to put in 50, just to make the difference, different amounts every time. 10 and 20 is 30, 30 and 30 is 60, 60 and 40 is 100, 150 is, of course, just that, 150. Let's run our program just the way I said it. So, let's enter 10 the first month, 20 the second month, 30 the third month, 40 the fourth month, 50 the fifth month, and at this point we should see, bingo, we got $150 in the bank. Do you see how running total works? Okay, so a very, very important type of equation we use in computer science. Okay, at this point I'm going to conclude the first part of my tutorial and pick it up from the